we start off from the very beginning of talking about the differences between boiling and evaporation. So a lot of us, we assume that evaporation only happens during boiling. Why? Because evaporation, we are talking about the water turning into water vapor or turning into steam. And when the water is boiling, we can very obviously see the water rising, becoming steam. It's very clear, it's very obvious. But then actually that is a very wrong concept. Why? Because evaporation is actually a process which happens at any temperature. That means anytime, anywhere, water is evaporating. Just that when the water is boiling, the evaporation actually is happening at the maximum speed, at the maximum rate. That's why we are able to see what we call as steam or water vapor. Because the steam, the water vapor, they are all gathered in the same place. That's why we are able to see this so-called steam. But actually today, if you have a puddle of water, okay, you let's say spill water on the floor, a puddle of water in your room, it is also going to evaporate. No matter where you are, when you are, what temperature it is, as long as there is temperature, as long as there is heat, water will evaporate. Because think about it. The very definition of water evaporating is when the water absorb enough heat energy, all right, to turn into a gas. Correct? Because water, they exist as a solid molecules, right? Sorry, liquid molecules. When the water, they absorb enough energy, right? When they move more violently and more quickly, more vigorously, the water molecules are going to evaporate into gas molecules. So in the end of the day, as long as there is this heat energy exists, it is going to turn into gas molecule. Okay? So that is the first difference, okay, between evaporation and boiling. Boiling, of course, happens only at 100 degrees Celsius, standard. And evaporation, it happens at any given temperature. That's the first difference. There is more. The second difference between evaporation and boiling is what? Evaporation, it is a process which only happens to the water molecules on the surface of the water. As a keyword, on the surface of the water. How about boiling? Boiling is not just the surface. Boiling, it is throughout the entire water. Boiling is throughout the entire water. This year end in chapter 9, I'm going to show you about heat, where you will understand about convection current. Then you will understand how does the water transfer the heat. But long story short, what happened is the water is going to keep pushing hot air and cold water and hot water around the boiling kettle. That is why we say boiling is a process which happens throughout the entire water. Bubbles start from the bottom, the whole thing keep on boiling, not just on the surface. But because evaporation only talks about the water molecules here which escape, that's why evaporation is only on the surface of the water. So you see that sounds like an easy concept, but a lot of detail that you must know. Okay, Ken. The second sentence here there says, during evaporation, the water molecules on the surface of the water gain energy from their surrounding. So when we say gain energy here, means absorb energy lah. Basically, we earlier have discussed absorb heat lah. Absorb heat from the surrounding, absorb heat from your gas stove, Bunsen burner, electric kettle, whatever it is. Yeah. When he absorb this heat energy based on the kinetic theory of matter from one, the heat energy is going to be converted into kinetic energy. And kinetic energy allows the water molecules to move rapidly, move vigorously, move quickly, move violently, going to escape into the atmosphere. Okay, now next one here, which I think you can put a star here. This is actually super K by question. Okay, read first. When water evaporates, some energy is lost, causing the rest of the water to become colder. This relates to the theory that when sweat evaporates, our body temperature will be cooled down. Okay, now I would like you all to recall back to Form 1, Chapter 3, homeostasis. Remember homeostasis, we learned about two things. Regulation of water content, which is talking about the kidney. What regulation of body temperature, which we have 5 techniques how to control your body temperature using your skeletal muscle, your hair, your sweat gland, your hormone, your blood capillary. Remember, one of the method is by producing sweat. Either you produce sweat or you don't produce sweat. We learned that when your body is overheating, when your body is very hot, you will start sweating. Your sweat glands will produce sweat. So we learned that when the sweat is produced, your body will cool down. Now, I've explained this thing actually last year to you all, but perhaps you did not understand it back then. I'm going to repeat here today. A lot of students, they are mistaken that when your body produces the sweat, that is when your body will cool down. Actually, it's not. When your body pushes out the sweat, when your body produces the sweat on your skin, your body is still very hot one. Nothing has changed. The sweat appear on your skin, your body is still boiling hot. Nothing has changed. You have not cooled down yet. The magic is not in producing the sweat. The magic is in evaporating the sweat. Yes. All right. So your body doesn't cool down from producing the sweat. Your body cools down from the sweat evaporating away. Only when the sweat evaporate away, that is when you will have the cooling effect. Okay. Why? Now let's relate that story with this story here. We already know that when water wants to evaporate, it requires heat energy. Heat energy converted to kinetic energy, the water will evaporate. So when the sweat is on the surface of your skin, what happens is it will absorb the heat energy from inside your skin. Remember, underneath your skin is boiling hot. Your blood is boiling hot underneath your skin. The sweat will actually absorb the energy from your blood and is going to increase in energy and evaporate away from your skin. So during the process of the sweat evaporating, they are going to carry away the heat energy and evaporate away. So what happens to your skin? The surface of your skin will lose heat. The surface of your skin will cool down. Makes sense. That's why I say last week, I mean not last week, last year I asked you okay? Last year I told you when you are feeling very hot and you are sweating, try and go and touch your face, touch your arm. You'll realize that your arm, your face, your skin is actually cold one. Not hot, but actually is cold one. Colder than inside your body. Why? Because the surface here, water is evaporating. Okay. So that is the reason why, all right, plants, they do transpiration. You have learned when plants do transpiration, of course, is used to pull the water up to the plant. Another reason, because the plants need to cool down. So they will cool down through the transpiration. Also, the reason why animals, they like to lick their body. Cats, dogs, kangaroos like to lick their body. Why? You say it's cleaning themselves. Actually, no. They lick themselves because they want the saliva to be on skin, on their fur. Their skin is not like our skin. They cannot sweat. For them, they will use their saliva and they will lick their body. Of course, in the process cleaning, because saliva is antiseptic, it can clean. But most importantly, they want to cool down their body. Today, if you go to the desert, you take a look at the kangaroos, they will be licking themselves, their arms, okay, their legs, wherever they can lick, they will try and cover themselves with saliva. Why? Because saliva is water. When the water evaporates, it's going to bring the heat away, cooling them down. Also, the reason why many animals, tigers and hippopotamuses and whatever, they like to stay in mud. They like to stay in the water, in a pond, in a lake, in a river, because that water cools them down. That water cools them down. Okay. Also, the reason why sometimes when your teachers see that you are sleepy, ask you to go and wash your face. Ask you wash your face for what? Your face dirty. No. Ask you to wash your face so that when you get water on your face, the water evaporate away. You will feel very freshened up. That's what I do. In fact, every time before I start a lesson, I would take the 5 minutes. All right, while I'm waiting for you all, I will go to the toilet. I will freshen up myself. I will, um, put water on my face and sometimes my arms and on my neck, so that in that few minutes I feel that cooling effect and I'm more freshened up to conduct the class for you. Okay, very good. So everyone understand this concept. We put one red color star there, very important. Okay, but Christian like to appear this Christian. Okay, so from here I'm going to proceed already lah. I'm going to proceed to the next important concept, which is rate of evaporation. Of course, after we understand what is evaporation, we need to know whether or not this evaporation happen quickly or happen slowly. Because we know that evaporation can either be fast or evaporation can be slow. Okay, just like I said just now, right? When the water is boiling, you can see that evaporation happens so quickly. That is when rate of evaporation is high. The ROE is very high. When the water is not boiling, when it's very low temperature, the water is still being lost, but then it's happening very slowly. That is when we say ROE is very low. Okay, so ROE, rate of evaporation, there is high and low. We use the word high and low to describe. So high ROE, okay, means that it is evaporating fast. High rate. Rate, this word actually means speed. Okay, so high rate or high speed of evaporation means that the water is evaporating fast. And when we have low ROE, means that the evaporation is happening very slowly. Happening very slowly. Understand? Okay, so you can see here on my notes that four factors which affect the rate of evaporation. Four factors which affect the rate of evaporation. Okay, so first factor here, okay, is regarding humidity. Okay, first we must understand, what does the word humidity mean? Actually, we learned a lot about this in geography already. Kelembapan, humidity. We describe the forest, we describe the environment, we describe the eclipse. Okay, humidity. So actually, humidity refers to the amount of water vapors that are in the area. Yeah. For example, in your room, what is the humidity in your room? Is it very wet in your room, or is it very dry in your room? You can very easily feel the effects. If your room is very wet, you probably feel that it's a little bit stuffy, a little bit uncomfortable, a little bit, and you will, get to see a lot of your things will actually spoil easily. If you have things that are made out of wood, the wood products will be destroyed very easily. If you have things that are, like cloth, the cloth will start to become moldy very easily. And those are the effects of, a very humid area. If it's a very dry area, you can also feel the effects very simply from the lips, from your lips. If you stay in your room for about 2 hours and your lips start to crack, start to become very dry, that means you are in a very, very dry room. So humidity here refers to the amount of water vapors. Now, what has the number of water vapors got to do with the water evaporating? You see, when water is trying to evaporate, they are trying to actually look for empty spaces in the air to evaporate. Yes, they are looking for empty spaces which they can go into, right? Because let's say lah, we have a box lah, okay, and inside here we put a beaker of water. What actually is this beaker of water trying to do when they are evaporating? They are actually trying to find empty spaces which they can slip into. Yes. So I hope you already roughly start to get the idea. Empty spaces, empty spaces means that when there are more people, it will be less empty spaces. A little bit harder for us to get in. But if you have very little people, means you got more empty spaces. It's quite easy to get in. If you don't understand, I draw for you here. Let's say we have two rooms. Let's say room A, okay, and room B. Okay, room A and room B exactly the same size, right? Or you can imagine that they are the same size. You are standing in the middle, right? You are deciding, should I enter into room A or should I enter into room B? Then, of course, you saw the number of people in the room, or you saw that room A got, wow, lot of people. Wow, packed to the brim. But then you saw room B, only a few people. Okay? Now, between room A and room B, if you are trying to enter the room, which one do you think is easier to go in without knocking into each other, without feeling very uncomfortable? Which one is easier to walk into, to move around, to go into? Because you are like the water vapor in the, you are like the water, and you are trying to get into the atmosphere. You're trying to get into the room. So which one is actually easy to get in? Of course, B, correct? Yeah, what do you say B? Room B, exactly. Why? Because not many people. Not many people means what? Wow. All of these here are empty spaces which you are able to walk around. Yes, freedom, exactly. You have the freedom to walk around all these places here, I'm saying. Okay. So that is what the water is looking for. When they are in a high humidity, we call this as high humidity, when the area has a lot of water vapors, so difficult to come out, very little empty spaces. So what happens? You are going to have a low rate of evaporation. Okay, so I put short form there, ROE. Short form, ROE actually means rate of evaporation. Okay, so it's going to have a low ROE here. And then in B, we have a very low humidity, not many water vapors. So you have a high ROE, easy to move here and there. So you can imagine this scenario here in this diagram. So from here, actually, students, most importantly, these four factors, what you need to know, you need to know the relationship between them. What happens when the humidity increases and decreases? What happens to the ROE? So from there, I give you the relationship. When you have the greater the humidity, the lower the ROE, the lower the humidity, the greater the ROE. Okay? This is the relationship between humidity and the ROE, rate of evaporation. This is what Christian like to ask you. How do we increase the rate of evaporation? How do we decrease the rate of evaporation? Then you must suggest the correct thing to do. Should we increase humidity? Should we decrease humidity? From here. Okay? Okay, so the next factor, temperature of surroundings. What does it mean? The temperature that is in our surrounding. So temperature, of course, I'm sure you know it has an effect. A hot day, a cold day, of course, there's a lot of effect. Question is, what is causing it to have a difference is the amount of energy. Okay, because when the surrounding is hot, means that there is a lot of energy. There is a lot of heat energy. So this heat energy will actually be converted into the kinetic energy. So the more heat energy that we have means that we got more kinetic energy. So the particles are able to evaporate faster on a hot day. If it is in a cold day, your heat energy not as much. So when you don't have as much heat energy, your particles, your water molecules will also have less kinetic energy. So it will take a longer time for them to accumulate the energy so that they can escape. Remember, they want to escape, become an water vapor. They are trying to accumulate energy. So if it's a hot day, you got a lot of the energy, it will take less time to accumulate. They can go easily. But if it's very little energy, then it will take long time until they can go. Okay. So relationship I write for you. This one quite simple one. The lower, the greater the I write here. The greater the temperature, the greater the ROE. Lower temperature, the lower the ROE. So notice all of the keywords that I put on screen for you all. The bolded one basically must answer according to the keywords there. So the next factor we call it as an evaporate. We call it as an exposed surface area. Okay. So exposed surface area, the third factor, it actually has got to do with what? The surface of the water which is exposed to the air. Yeah, because water molecules, they are trying to escape. To escape, they must have a door. They must have somewhere. They must have space to escape. So from here, I show you all. I draw for you two different cups. Say that we have one cup that looks like this size, and we have a cup that looks like this size. Almost don't consider as a cup anymore, almost like a bowl already. And then of course we try and draw the water on the inside. Okay, so if you are the water vapor and you are trying to escape, which one do you think is easier to escape? Draw some arrows lah. Draw some arrows. You can escape from here, here, here. Limited space on. Limited space on. But here, wow, can go from here, from here, from here, from here, from here, from here, from here. All kinds of space you can go out. Okay, so the more space that we have, the bigger surface area we have, the more space we have, that is easier for the water molecules to escape. So your ROE is going to be higher. So if I want to write out the relationship, what should I write? Of course, the greater the exposed surface area, the greater the ROE. Lower the exposed surface area, the smaller cup, the lower the ROE. Okay, exposed surface area. Okay, so after you draw the cup, from there I will explain to you regarding air movement. Air movement also you need the cup one. Okay, so now I'm gonna use the bowl diagram instead lah. So let's use the bowl diagram instead. I show you the last one for air movement. So let's say lah, okay, you have the bowl like this, the water like this, and the water it already evaporated. So you can see in the area there is a lot of water vapor. Now, what happened is air movement, this factor, actually, there are two parts. The first part, actually, you talk about air movement. By the way, air movement actually just means wind. Whether or not it's wind blowing. So, one part of it is talking about air movement, talking about wind. The second part actually is story from humidity one. Story from humidity. Okay, you see why? Okay, so at the beginning, we say there is a lot of water vapor here. Now, suddenly what happened? The wind comes. When the wind comes, what happened? They will blow the water vapor away. So the water vapor which are in this area, they will actually be blown to somewhere else, which is, let's say here. Some will stay there, of course. Some of them will come over here. So my question is, do we have more empty spaces now? Oh yes. Oh yes, we suddenly have got more empty spaces now. So this is when the water is able to evaporate easily here. So the story is, when there is wind, the wind blow away the water vapor, creating more empty spaces for the water to evaporate. If there is no wind, all of the water vapor is blocking you. You will not be able to come up. So the story. The greater the air movement, the more wind there is, the greater the ROE. The lower the air movement, the lower the ROE. So actually the story, if you want to be even more detailed, actually the detailed story come from where? It actually come from the story of humidity, where when you have more air movement, you actually got lower humidity. Yeah, because you are blowing away the water vapor. So that is when you will have higher ROE. You see, When you have lower air movement, a greater humidity, you will have lower ROE. You see? So this is more detailed. But for your level, of course, this is more than sufficient. Okay, so these are the 4 factors of rate of evaporation.